In the previous videos, we looked at ways of describing data with visualization tools like the bar chart, the pie chart, and the histogram. In this episode of our screencast, we're going to be looking at ways to describe distributions using numbers. And the two things we want to describe principally are center, also called central tendency, and spread. Center is a measure of the middle or average of the data set, what is a typical value, and spread is how much the data varies from its average value. To look at an example of this, I've collected cars in the category of compact wagons, and these are all the cars from a single model year. We're looking at their several properties, the model of the car, the make of the car. I can see I have Kias, Volvos, Chevrolet, Buick, Subaru, etc. And we know how many cylinders they have. These either say 4 cylinders or not a number, which, let's see, what are those cars? The Chevrolet Bolt EV and the Nero Electric by Kia. So these are clearly both electric cars. That's why they don't have cylinders, because they don't have internal combustion engines. And we have the city miles per gallon and the highway miles per gallon. Let's take a look at a visualization of this. I used a Python script to generate a stem plot like we talked about in the last example, and I can see that most of the data fall between 29 and 49 miles per gallon on the highway, with just a couple outliers here, a couple atypical data points, 102 and 108 miles per gallon, so you might guess which cars those are. Let's look at ways of measuring the middle of this distribution. The first way we're going to look at is called the mean. You've probably heard of it. It is also just called the average, and it is denoted by x bar. This is pronounced x bar. And what it means is take all the individuals, all the variables for all the individuals in your set from 1 to n, add them up and divide by n. This is just what we usually mean when we say average. Another notation for this is our sigma notation. This means sum from individual 1 to individual n, adding up the property that we're looking at, in this case miles per gallon, and then divide by n the number of individuals. So that's a little bit more compact way of writing the same idea. Now we can see a histogram for these 30 automobiles and their highway miles per gallon. We can see the two out here on their own, the electric vehicles, and this big clump of data ranging from 29 to around 50. Plotting the value we get when we add up all of the highway miles per gallon and divide by 30, I can see that x bar, the mean miles per gallon, is 39.27 miles per gallon. So if I eyeballed this, I would think that the center of the distribution was closer to around here, but it has been pulled away, and that's the influence of these outliers over here. So we have another way of measuring the center of a distribution that'll be less influenced by highly atypical values like this. Let's see how we do that. This number is called the median, or the middle data point. To calculate the median, we take all the data, here are all of the miles per gallon for those 30 cars, and we put them in order, like so. And I notice that I have 15 in the top and 15 data points in the bottom of my list here. I just split it in half because it wouldn't fit on the slide. And the median, if they're an even number of data like this, is just the average of the two middle data points, which here are 34 and 34. The average of 34 and 34 is, you guessed it, 34. So the median of this data is 34. This looks like more what I would call the middle of this distribution. Although, if we made this distribution out of some material, like a sheet of metal, the place it would balance, including these points out here, would be x bar, or the mean. The median, though, is the point at which half the data are less than that number and half the data are more than that number. What would happen if we removed these two biggest data points? Well, let's go back to the data. I can see that I'm crossing out 102 and 108. Since I've removed two data points, it's moved my middle of the distribution by 1. So instead of being between 34 and 34, we're now between 33 and 34. So the median would be 33.5, which is not that big a difference from the 34 that we had before. So we can see that these two outlying data points, the two electric cars, didn't really pull the mean too far. They pulled it a little bit, but compared to the median, this is a much more robust measure. We say that the median is a robust measure of central tendency because it is not strongly affected by atypical data points, which we call outliers. The median, though, is a better number to use if we have data that's highly skewed. So if you see skew, which looks like this, negative skew means that we have a long tail on the left end of the data, the smaller end of the data value, and positive skew means we have a long right tail. There are a number of reasons you might see data like this, like suppose we had test grades. They are always going to have negative skew because there's a ceiling at 100%. You can't get scores higher than that, but you can get scores much lower, so it's not uncommon to see this kind of shape for test scores. If we looked at something like survival times after treatment for a life-threatening condition, we might see a positive skew like this, so there's a typical survival time, and then individuals who fare much better with much longer survival time. So different categories of data exhibit skew, and those are well known for certain categories of data. Again, if we see skew like that, you want to report the median and not the mean as a measure of the center. So important to note also, the mean might be a value that doesn't even occur in the data set. So if I had bimodal data with two distributions separated like this, well, I'd have a problem in either case there. But for data that has several peaks, you're usually going to get a more realistic measure of the median of the center by looking at the median than by looking at the mean. The median will be a number in the data set, or at least the average of the two middle values. And one advantage of the mean, on the other hand, is that the mean times the number of data points will always equal the total of the data points, which can be a handy thing to know.